Hello everyone, and you got another video tutorial of doing an Sn2 mechanism organic chemistry substitution of alkyl halide. Alright, so you can see that I have here our substrate and our nucleophile solvent, and we're going to do a substitution reaction. Now let me just review quickly. Substitution reaction is when we have our alkyl halide and the halide actually goes away and the nucleophile binds to the alkyl halide. Now the Sn2 mechanism is affected by four things. First of all, we need unhindered substrates, and it works the best with first substrate, then second, and then third. And what that means is just how many R groups connected to the carbon halogen. So if it's one R group, it's 1, 2 R groups is 2, 3 R groups is 3. Simple as that, that's the only thing. And first is better than third because the transition state for the first one is much more stable than the transition state for the third one. Because the third one, there are too many things connected to the carbon, making it very unstable. Okay. Now the second thing that we look at is the leaving group. The leaving group should be a good leaving group. Good leaving groups are Cl minus, the charge is minus, Br, iodine. Good leaving groups are actually the weak bases. And third thing that we need is a nucleophile. We need a good nucleophile, meaning a strong base is a better nucleophile. It increases down a column, and a negatively charged nucleophile would be always better than a neutral. Third thing that we need is a polar aprotic solvent, and we need aprotic and not product because product can form hydrogen bond that can surround our good nucleophile and actually prevent from this reaction of happening well. Okay, so let's first look at this carbon. This is our first carbon. We look at this carbon because it's connected to the Br, our halogen, and it is actually connected to 2 R groups, so that means this is the second carbon. This is good because the Sn2 mechanism can happen in here. In addition, we have a really strong base, and that is a very good nucleophile. And we have aprotic solvent. So all the conditions favor our Sn2 mechanism. What actually happens in the Sn2 mechanism? So showing the mechanism, it's a one-step reaction. The rate law for this reaction is our rate constant, our substrate, and our nucleophile. So they all affect the rate. If we change each of those, they will affect the rate. And what actually happens, so on this oxygen, on the OH is actually oxygen connected to hydrogen, and we have electrons around. So we have 1, 2, 3, 4, 5, 6 electrons. That what gives the oxygen negative charge. First thing, we have the bond breaking. So this bond breaks and gives the pair of electrons to the bromine. Then these 2 electrons coming from the other side, and that's what happened actually in Sn2 mechanism. It comes from 180 degrees from the other side, and you're actually going to be in a different position, and I'll explain, and forms a bond. So what actually happens, we get this molecule. The Br goes away, so we get the sodium and the Br together because we cannot have charge, and this is just salt. And here we actually, because we came from the back side and this was coming towards us, so our results should be coming back, OH. So this is actually our result after the Sn2 mechanism. We get this molecule with the hydroxide, the alcohol, and that's it pretty much. Hope this was helpful.